Okay, so we are looking at page 150, talking about inverses. So this is a horizontal line test. What this is used for is if we want to know if the inverse of a function is an actual function itself. So every time we're given a function, can somebody get that? We're given a function, we want to see if it passes the vertical line test. So yes, this passes the vertical line test. So that's good. And then we want to check to see, thank you, we want to see if the original function passes the horizontal line test. So this does, because it's only touching in one spot. So this passes the horizontal line test. That's what tells us that the inverse is a function. This one, though, I can see that the inverse is not a function, because if I check it in the horizontal direction, that is not going to touch in just one spot. It's touching in two spots. So that's why the inverse of this is not a function. Here's what people get confused, though. It doesn't matter whether or not the inverse is or is not a function. This is a function. Here's what the inverse would look like. If I reflect over this line, can you see how the inverse is not a function because it doesn't pass the vertical line test once we graph the inverse? Okay, so that's the kind of thing, that's why that horizontal line test works, because we're actually like almost reflecting it ourselves. So now we're going to look at some problems here on page 152. We're just going to look at 11 and 12 first. We want to use the graph to determine whether the inverse of f is a function. So this is the original. Both of these are functions. These originals are both functions. But I want to know, is the inverse a function? So you guys do those on your own now. Decide whether 11's inverse would be a function and whether 12's inverse would be a function by using that horizontal line test. Joey, what did you say about number 11? No, it's not, is it? No, inverse not a function. And why is that, Joey? Right. Does not pass horizontal line test. All right, what about number 12? What do you think there, Maya, yes or no? If I put a horizontal line at any spot, does it only touch it in one spot? Right in here it's not, does it? If I put a horizontal line right there, it touches it in 3 spots. So this again is going to be no. The inverse is not a function. The original one's a function, but not the inverse. And we could say because of horizontal line test. We'll call that HLT, horizontal line test. So that's a quick way to tell whether or not that inverse is going to be a function. All right, now let's go back up here, and we're actually going to find inverses. So what we're going to have to do is say this is y. So we change our y to an x, and we change our x to a y. But before we go any further, we want to write out the domain and range of this. Do you guys remember what an x to the third function looks like? Yep, some of you are showing me. If you don't remember what x to the third looks like, you can do this. X raised to the third, zoom 6. Here's what x to the third looks like. This is going to be a shift to the left 2. So it's going to look like that. So there's the original function. We're going to write out the domain and range of this original function. The domain is going to be negative infinity to infinity. They're all real numbers. The range is also negative infinity to infinity. That's good news, because what that means is with our inverse, we don't have to worry about anything. There's not going to be any restrictions. Because the range of this is all real numbers, the domain of this is going to be all real numbers. So now we're going to solve it. To solve this for y, what would I do first? Would I subtract 2 or cube root it? Take the cube root first. So now we're going to have the cube root of x equals, the cube root of something cubed is just y plus 2. Now we would subtract 2. And I call that f to the negative 1 of x. That's the name we're giving to that inverse. So to graph this, what kind of a shift is this going to be? If it's outside of the radical, it's going to take it down 2. The cube root function, hopefully you remember what it looks like. I'll graph it in case you don't. You can go to math, cube root x. I'll make it bold so we can tell the difference. So here's what x to the third looks like, and here's what x to the cube root of x looks like. You can see those are actually inverses of one another. So now I'm going to have a shift down 2 units, and it's going to look like that. And you can see that those are inverses, that they're reflections of the line y equals x. So that's good. All right, looking at the second one, right here, we're told x must be greater than or equal to 0. That's a domain, guys. That's a domain. So now we might want to also find the range here. So I'm going to graph this function. You should know that y equals x to the fourth is just like y equals x squared. It's going to have that end behavior where it opens up at the end. 1/3 is just going to be a vertical stretch, or shrink of 1/3. So instead of going out 1 up 1, we go out 1 and up 1/3. Because we have that vertical shrink. But it tells me I'm only graphing it when x is greater than or equal to 0, so I'm not graphing it over here. Normally I would, but this restriction tells me I'm only graphing it over here. So that's the way it's going to look. Now what's the range of this function? I go from the bottom. What's the first y value we come to? Good. So I can either call it 0 to infinity, or I can say y greater than or equal to 0. Whatever this range is, that's going to be the domain on my inverse. So on my inverse, the domain is going to have to be x must be greater than or equal to 0. So I'm going to go ahead and solve it. My y becomes x, my x becomes y. What do we do first? Ty, what would I do first? So I take the fourth root, or do I multiply by 3? And now I'm going to take the fourth root. And normally when we put the fourth root, we put plus or minus the fourth root of radical 3x, the fourth root of 3x. But think about graphing the square root function. The square root function looks like that. The negative square root function looks like that. Am I going to graph both of those? Would it still be the inverse of that if I graph both the top part and the bottom part? No. So I'm not even going to have plus or minus. I'm just going to have the positive. So f to the negative 1 of x is actually just going to be the fourth root of 3x. But I would also have to make this statement that x must be greater than or equal to 0. Because if it's not greater than or equal to 0, then I get into imaginary numbers. So that's another reason why I have to state that. Okay? Any questions on that? All right, down here at the bottom, it says determine whether the functions are inverses. Well, I'm just going to find the inverse. So to find the inverse, x becomes y becomes x. And we have to solve this for the new y. So what do we do first, Becky? Trying to get y by itself, we need to get rid of -1. So what are we going to do? Right? So now we're going to have x plus 1 equals 4/5 y. Joey, how do we get rid of the 4/5? Right, both sides. Everything gets multiplied by 5/4. So now when I distribute this through, I'm going to have 5x plus 5 all over 4. That's going to be our inverse. Is that the same thing as what they have here? No. So therefore, no, they're not inverses. Because when I distribute that, 5/4 times x is 5/4 x, 5/4 times 1 is 5/4, so they are not going to be inverses. Okay, you guys go ahead and try this one now. Just switch your x and your y and see if they would be equivalent. Okay, so here's what I came up with when I found the inverse. The question is this actually equivalent, though, to that? Let's see, this is 2 plus the 5th root of negative x plus 6. This is 2 plus 6 minus x to the 1/5. Are those the same thing? They are, aren't they? See how I could rearrange this and make it 6 minus x? And if it's the 5th root, it's really 6 minus x to the 1/5. And then that 2 could go out in front. So they are equivalent there. So we would say yes, they are inverses. Okay? Any questions about inverses? So remember, we can quickly find out whether the inverse is going to be a function with that horizontal line test. And speaking of that, you could also look at this and you could say, well, this inverse is a line. And so that, if that's a linear function, they're not inverses anyway. But we could look at something that is an inverse, like this one is the inverse, and that's just a line. And lines are always going to be functions, as long as they're not vertical lines, which that's not. Okay, very good.